Hello. Hello.
Good evening, sir.
Yeah, good evening. Okay, so do you have any questions from Ellipse that you want to discuss? Any doubts?
No, not yet. I had started solving, but
You are able
so
to do it right now, right?
yeah.
Okay. So we'll finish the theory by doing hyperbola. This is the last one. And we'll just do some questions at the end. So basically, this is a conic section with eccentricity greater than 1. The definition is same, PS is equal to EPN, right?
Yeah.
And again, you'll get a 2-degree curve. And in order to identify the 2-degree curve as a hyperbola, what you have to say is del should not be equal to 0 and h square minus AB should be greater than 0, right?
Yeah.
If you choose your focus and directrix as these points, say directrix is this, 1 second, just hold on.
Yeah.
Yeah, so if you choose it like this, then the equation becomes x square by a square minus y square by b square is equal to 1. This is your standard equation. Here you can get e square comes out to be 1 plus b square by a square. Okay.
Yeah.
Now the graph looks like this. It is an open curve. This is your center 0, 0. The directrices are here and here. And the directrices are a by e and x is equal to minus a by e. The foci are ae comma 0 and minus ae comma 0. And this is your axis. This axis is called transverse axis. Transverse axis. And this axis is the conjugate axis. And this point are minus a comma 0 and a comma 0. And there will be a point here 0 comma b and a point here 0 comma minus b, right?
Yeah.
Now these are your standard things to know. So eccentricity can be written as 1 plus conjugate axis square by transverse axis square. That is your e square. Okay. So conjugate axis length will be 2b and transverse axis length will be 2a. Correct?
Yeah.
The reason we are writing it like this is sometimes your axis could be interchanged. You could have an ellipse hyperbola like this, right? And
Yeah.
this. That is called a conjugate hyperbola. In that case, the transverse axis is this vertical line and conjugate axis will be this. So eccentricity will be 1 plus a square by b square in that case, right?
Yeah.
Now, this, we know all of these points, vertices, foci, directrix and stuff. Now, if you have, okay, one latus rectum will be the line perpendicular to transverse axis. It will pass through the point AE comma b square by a and AE comma minus b square by a, just like in an ellipse. Your length of latus rectum becomes 2b square by a, right?
Yeah.
Now, there is a property of the focus here that the distance between the focal distances, the difference is going to be 2a. So if P is a point on a hyperbola, point on the hyperbola, your focal distance can be written as PS1 can be written as A plus EX1, A plus EX1 and A minus EX1, right?
Yeah.
PS2 would be A minus EX1. So that when you subtract, you get 2A. Okay. And basically P point can be written as X1 comma Y1, right?
Yeah.
So you subtract, you get 2A. Now, one thing to realize here is if the figure was like this, what is the significance of your B point, right? Like this is clear, like A minus A comma 0 is one vertex and A comma 0 is another vertex, and 2A becomes length of the transverse axis. But how do we know where to put the B, right? Like 0 comma B and 0 comma minus B. Like what is the significance of this B point here, right? Because it's not like it is part of the curve or something, right?
Yeah.
On an ellipse, it was clear what B was because B was lying on the curve, right?
Yeah.
Here it is not lying on the curve. So what does it mean? So it means it defines the width of the hyperbola. By width of the hyperbola, what I mean is this, like if I make a parallel line parallel to the x-axis passing through B and through minus B, and lines perpendicular to x-axis passing through A and minus A, then you will get a rectangle, right?
Yeah.
Rectangle has width here 2B and here 2A, right? Now, the diagonals of this rectangle are the asymptotes of the hyperbola. So this is one diagonal and this is another diagonal, right?
Yeah.
And so diagonals are a straight line. So if you try to find equation of the diagonals, you will see it is y is equal to b by ax and y is equal to minus b by ax, right?
Yeah.
This diagonal is your b by ax and the other one is minus b by ax. Now what is special about this line? So these lines are known as asymptotes to the hyperbola, and by the asymptotes, what we mean is a line that touches the hyperbola, that touches the curve at infinity. What is the meaning of that? Touches the curve at infinity. It means that it will not touch the curve ever at a finite point, but it is getting closer and closer to the curve as you go away to infinity. Okay.
Yeah.
So basically, there is no intersection. It is just like this. It is getting closer and closer, right? There is
Yeah.
no intersection though. So if you think about it, any line that lies in this region, right? Any line through the origin that lies in this region will cut the curve at 2 points, right?
Yeah.
And any line that lies in this region, right, will not intersect the curve, right?
Yeah.
So basically, you can say that this is a limiting form of a tangent, right? It is like tangent at infinity, not tangent at a finite point, but tangent at infinity. So it sort of determines how wide your hyperbola can be, right? The curve has to be within the two asymptotes, right?
Yeah.
It cannot cross over and go to the other side because then there will be an intersection, right?
Yeah.
So your asymptotes are these lines, and therefore B definitely determines the width of your hyperbola, right? B
Yeah.
and A together, because B and A together determine the slope of this asymptote and this asymptote. So your hyperbola is constrained to be within this section, right?
Yeah.
So if you think about it, let's say my equation of the curve was this, the standard hyperbola. and y is equal to b by ax and y is equal to minus b by ax are the two asymptotes, then you can easily say that this is y by b minus x by a is 0, and this is y by b plus x by a is equal to 0. So the pair of straight lines representing the asymptote is simply x square by a square minus y square by b square is equal to 0, right?
Yeah.
So this is asymptote pair, asymptote pair, and this is your hyperbola. Now, what we will see is if I write the equation like this, x square by a square minus y square by b square is equal to minus 1. This is called your conjugate hyperbola. Conjugate hyperbola, why? Because if you take the minus this side, it becomes y square by b square minus x square by a square is equal to 1, right?
Yeah.
Conjugate hyperbola will be the hyperbola that is using the same transverse and conjugate axis, but the transverse is alternate with the conjugate, right? For this one, whatever was transverse, it is conjugate for this one, right? Like this is curve 1 and this is curve 2, right?
Yeah.
Basically, you have interchanged your transverse and conjugate axis, right?
Yeah.
The asymptotes are common for both the curves, correct?
Yeah.
It's like this. They have common asymptotes, but you are getting a second hyperbola. This is a conjugate hyperbola. So one key thing to remember here is if you write the equations like this, for example, if you write the equations like this, x square by a square minus y square by b square minus 1 is 0. And here x square by a square minus y square by b square is equal to 0. And here x square by a square minus y square by b square plus 1 is 0, right?
Yeah.
These three equations, this is equation of hyperbola, this is asymptote, and this is conjugate hyperbola, right?
Yeah.
Now, if you see equation of conjugate hyperbola minus 1 is equal to the equation of the asymptotes, right?
Yeah.
And minus 1 is equal to equation of the normal hyperbola, correct?
Yeah.
So the thing to remember here is that the three equations differ by constant values. Like it is minus 1 in this case and minus 1 in this case. And you can say in general, the equation of a hyperbola asymptotes to it, pair, asymptote pair, and the conjugate hyperbola will differ by the same constant. Will differ by the same constant. Now, why am I making a big deal out of this? Because in general, the equation of the hyperbola will not always be in this straightforward form, right?
Yeah.
Correct. In general, you could have a 2-degree curve like this, which is a hyperbola, right?
Yeah.
Now, suppose you got a 2-degree curve like this, and somebody asked you, find the equation of the asymptotes to this hyperbola, right? Correct.
Yeah.
Then it might be slightly annoying because it might be really hard or impossible almost to convert it into this form, right?
Yeah.
If you get a 2-degree curve, it will be difficult to convert to the standard form, even though there will be some standard form, because actually the hyperbola doesn't have to be like this, right? It can be a rotated and shifted hyperbola, right?
Yeah.
You could shift the origin, you could rotate the axis, many things can happen because of which it was a complicated equation, right?
Yeah.
If you want to find the asymptotes, however, you can use this fact now. That the equation of the hyperbola and its asymptotes will differ by some constant value, right?
Yeah.
If it is not a standard hyperbola, it may not be minus 1 or plus 1. It may differ by some other constant. So what do we do in such cases? What we say is, okay, let's say ax square plus 2hxy plus dy square plus 2gx plus 2fy plus c is equal to 0 is a hyperbola. An equation is given to you, therefore you know the values of a, b, c, h, f, g, right?
Yeah.
And you want to find out the the actual asymptote equation for this hyperbola, right? So what
Yeah.
you will say is, let's say the equation of asymptotes, because we know it differs by a constant, is just this plus some k, right?
Yeah.
You will say this equation of asymptotes will be this plus some k. K is some constant, right? And now here, because it is supposed to be an equation of pair of straight lines, you can do del is 0, right?
Yeah.
And del is 0 will suddenly, only thing has changed is c has become c plus k. And then you can find k from there, right?
Yeah.
Once you get k, you get the equation of asymptotes you get, right?
Yeah.
And once you get that, you also get a third thing. Now you can add a plus k to that, and the equation of conjugate hyperbola also you get, right?
Yeah.
It will be conjugate hyperbola will be plus 2k, right? Because the difference between this and this, and difference between this and this has to be same, correct?
Yeah.
So given your standard hyperbola equation in a general form, we can find conjugate hyperbola and asymptotes if we use this fact that they differ by a constant k, right?
Yeah.
The first step would be to always find the asymptotes, because you will say del is 0 and find the k from there. Are you understanding?
Yeah.
Okay. So that is one thing to note. Then one simple result that you can derive, if E1 is the eccentricity of a hyperbola and E2 is the eccentricity of the conjugate hyperbola, then you can easily derive that the eccentricities E1 and E2 will follow this relationship, right?
Yeah.
This is a simple relationship that you can get. The next thing is, what is a parametric point on the hyperbola? What is a parametric point on a hyperbola? So let's say you have a hyperbola like this, x square by a square minus y square by b square is equal to 1, right? Then it is
Yeah.
obvious that a sec theta comma b tan theta will satisfy this, right?
Yeah.
So this is your parametric point on a hyperbola, but it is not just enough to know that this is the parametric point. We should understand what theta really is, right? Because if you remember, in an ellipse, a cos theta b sine theta was the parametric point, but theta was not this angle, right? Theta
Yeah.
was this angle, correct?
Yeah.
Similarly, here also, you will try to understand what theta stands for. So if you have a hyperbola like this, if you have a hyperbola like this is minus a and this is a, you can make an auxiliary circle to the hyperbola. The auxiliary circle to the hyperbola is the same thing like in an ellipse. It is a circle with diameter 2a, right?
Yeah.
So auxiliary circle is basically x square plus y square is equal to a square, just like in the ellipse. Now, on that auxiliary circle, if I put any random point, that point will be a cos theta, a sin theta, right?
Yeah.
Correct.
Yeah.
Now draw a tangent to this circle at this point. Okay. Draw a tangent to the circle at this point. So what is the tangent to this? It would be x cos theta plus y sin theta is equal to a, right?
Yeah.
That is tangent to the auxiliary circle at the point theta. Now, this tangent intersects the x-axis at what point? So put y is equal to 0, you get x is equal to a by cos theta, right?
Yeah.
Or a sec theta, correct?
Yeah.
So this point is a sec theta comma 0, right?
Yeah.
And now you simply draw a perpendicular line to it, and this point is the corresponding point on the hyperbola. It will be a sec theta b tan theta, right?
Yeah.
So in case of a hyperbola, the construction is a little more complicated than in case of an ellipse, where you just took a circle and dropped a perpendicular from here, right?
Yeah.
In a circle case, in the ellipse case, it was simple. Here, you have to take the auxiliary circle, a point on the auxiliary circle, draw a tangent, and tangent will cut the axis, transverse axis at this point, and from there you can find a corresponding point on the hyperbola, right?
Yeah.
So that is your parametric point on the hyperbola. It will be useful because we have reduced the number of variables, so it will be convenient now to write tangent normal equations in terms of those things, right?
Yeah.
Some basic stuff that we have done many times now, similar things here. So if you have a line and a hyperbola, then when will it cut it and when will it be tangent to it? Those things are obvious. You just solve the line and the hyperbola and take the conditions on discriminant, right?
Yeah.
Discriminant is 0, it is tangent. If it is greater than 0, it is intersection, and less than 0, then no intersection, right?
Yeah.
From here, you will get the condition that c square is equal to a square m square minus b square for tangent. For tangent. So therefore, you get equation of tangent in the slope form will be mx plus minus root over a square m square minus b square, right?
Yeah.
And tangent equation can be written in other forms. The point form is x1 by a square minus y1 by b square is equal to 1, right?
Yeah.
And if you put parametric point x1 as a sec theta and y1 as b tan theta, you'll get x sec theta by a minus y tan theta by b is equal to 1, right?
Yeah.
So these three are your regular tangent equation. Normal equations we know how to get. You will just use the fact that y minus y1 is equal to slope of normal and all, right?
Yeah.
So from here you will get slope of tangent, and you'll do slope of normal minus m by x minus x1. And if you simplify it a little bit, it comes out like this: a square x by x1 plus b square y by y1 is equal to a square minus b square, a square plus b square. And a square plus b square for hyperbola is a square e square, right?
Yeah.
This becomes your normal equation. If you put x1 and y1 as a sec theta, a b tan theta, you get another form of the normal equation, which is ax by sec theta plus by by tan theta is equal to a square plus b square, right?
Yeah.
That is your normal equation. Then some stuff that we have discussed, for example, in the case of ellipse, we'll just do the same thing for hyperbola. So for example, if there are 2 points theta 1 and theta 2 on a hyperbola, and tangents at theta 1 and theta 2 intersect. Tangents at theta 1 and theta 2 intersect. So obviously we can find the equation and solve it, but it is convenient sometimes to remember the point of intersection. The point of intersection would be a cos theta 1 minus theta 2 by 2 by cos theta 1 plus theta 2 by 2, comma, b sine, this is your y coordinate, theta 1 plus theta 2 by 2 by cos theta 1 plus theta 2 by 2. This is your y. Remember, we had written a similar thing for ellipse also.
Yeah.
The 2 points tangents intersecting, right?
Yeah.
Then one more thing that is important is equation of chord joining theta 1 and theta 2. If there are chord through theta 1 and theta 2, what is the equation of the chord that joins them? It is x by a cos theta 1 minus theta 2 by 2 minus pi by b sine theta 1 plus theta 2 by 2 is equal to cos theta 1 plus theta 2 by 2. Okay.
Yeah.
Again, similar to the equation we had for a high ellipse, you just need to write them down properly and make sure you understand the differences in these equations. These are useful in problems, so you should better remember them because you don't want to derive it. It's too long. Okay.
Yeah.
Then the third thing is director circle. So what is the locus of the point which moves such that perpendicular tangents can be drawn from there to the hyperbola, right? That comes out to be x square plus y square is equal to a square minus b square. Okay.
Yeah.
So here, obviously, if b square is greater than a square, then circle is not real, right?
Yeah.
And no such circle, right?
Yeah.
And if b square is equal to a square, then it is just a point. It's a point, right?
Yeah.
And the way to get the director circle locus we discussed for ellipse, right? So same method. You say tangent equation should be like this, right?
Yeah.
And tangent should pass through h comma k, right? Put that here, and you will get a quadratic in m, right?
Yeah.
And m1, m2, the roots of the quadratic should be -1, right?
Yeah.
So from the equation, you will get an m1, m2 value in terms of h and k. That will give you this locus, right?
Yeah.
Then fourth thing is chord of contact. Chord of contact is the chord joining points of contact at 2 points of two tangents. So if this is a point of contact of a tangent, and let's say this is a point of contact of another tangent, right? This is the chord of contact, right?
Yeah.
Chord of contact with respect to an external point. This is an external point from where two tangents were drawn, right?
Yeah.
From here you have drawn two tangents. Now you want to find the chord here, chord of contact. And that equation is simply t is equal to 0. T is equal to 0 from the point where tangents are drawn, right?
Yeah.
All this should be familiar, right?
Yeah.
Then last thing in this section is t is equal to s1 will be equation of chord with a given midpoint, right?
Yeah.
With a given midpoint. The one point here is the midpoint. Okay. Then one particular thing that you need to be clear on is what is a rectangular hyperbola. Rectangular hyperbola. So rectangular hyperbola is the special case of the standard hyperbola where you can say A is equal to B if, right?
Yeah.
A is equal to B, your eccentricity becomes root over 1 plus A square by A square, right? So root 2, correct?
Yeah.
And the equation starts looking like this: x square minus y square is equal to A square, right?
Yeah.
So that is your rectangular hyperbola, but sometimes you will see that they will write rectangular hyperbola like this, right?
Yeah.
You might have seen this as an alternative form of rectangular hyperbola, right?
Yeah.
So how come this equation also is rectangular hyperbola and this equation is also rectangular hyperbola? Do you know why?
No.
Okay, you have seen this form, right?
Yeah.
So why is that happening? So basically, normally hyperbola was like this, and for rectangular hyperbola, basically this distance is same as this distance, right?
Yeah.
B is equal to A, so this becomes a square, right?
Yeah.
And the asymptote becomes what? Y is equal to x and y is equal to minus x, right?
Yeah.
y is equal to x, y is equal to minus x. Now, okay, this is my axis of y, this is my axis of x, this is my asymptote, and this is the other asymptote, right?
Yeah.
Now, what happens if I rotate my axis y and x and make the new axis along the asymptotes, right? This is y dash and this is x dash, right?
Yeah.
Why can we do that without changing much? Because still you know that y is equal to x and y is equal to minus x, they have 90-degree between them, right? You can rotate the axis, right?
Yeah.
So it is still going to be a rectangular Cartesian system because original axis also had 90 between them and this axis also has 90 between them, right?
Yeah.
So now what I want to see is how does the equation change when I go from the xy axis to the x dash y dash axis, right?
Yeah.
So this basically means that I'm rotating my axis in a clockwise direction by 45-degree, right?
Yeah.
So that is what we will try to figure out. How does the equation change? So rotation, how do you do? 1 second, just hold on.
Yeah.
Yeah, so basically we have to understand how do we rotate things if your axis has changed, right?
Yeah.
So let's say my new axis is this one. This is your x dash and this is your y dash, and originally was y and x, right?
Yeah.
So the angle is 45-degree rotation, right?
Yeah.
So if there was a point here in the old axis with coordinates x and y, right? Then I can draw a line which is radius vector and say this is r distance from the origin, right?
Yeah.
And that was, let's say, at angle alpha, correct?
Yeah.
So x could have been written as r cos alpha and y could have been written as r sine alpha, right?
Yeah.
Now in my new axis, my origin has not shifted, right?
Yeah.
So the distance is still r, right?
Yeah.
But the angle is now this angle, right? With the x-axis,
Yeah.
correct? Makes sense, no?
Yeah.
So in the new axis, my x coordinate x dash should be r cos alpha plus 45. And y dash should be r sine alpha plus 45. Correct?
Yeah.
So now if you expand this out a little bit, it becomes r cos minus sine sine. So this is r cos alpha 1 by root 2 minus r sine alpha 1 by root 2, right?
Yeah.
And this is clearly x by root 2 minus y by root 2, right?
Yeah.
And this becomes r sine cos. So this becomes y by root 2 plus x by root 2, right?
Yeah.
Now I know y dash in terms of old coordinates and x dash in terms of old coordinates. However, what I want to do is instead of x and y, I want to put x dash y dash, right?
Yeah.
So if I add these two equations, you will get x dash plus y dash is equal to 2x by root 2, so root 2x, right? So x is equal to x dash plus y dash by root 2, right?
Yeah.
And if I subtract these equations, right, I get root 2y is equal to y dash minus x dash, right?
Yeah.
So y is equal to y dash minus x dash by root 2, right?
Yeah.
these are my old coordinates in terms of new coordinates, right?
Yeah.
So basically xy has become x dash y dash now, right?
Yeah.
So old equation of the hyperbola was what? X square minus y square is equal to a square, right?
Yeah.
And if you put x for this, you will get x dash plus y dash whole square by 2 minus y dash minus x dash whole square by 2 is equal to a square, right?
Yeah.
This becomes, when you do it, you get plus 2xy minus minus. So plus 4xy, 4x dash y dash by 2 is equal to a square, right?
Yeah.
So you get x dash y dash is equal to a square by 2.
Yeah.
In the new rotated axis, I will not call it x dash y dash later. I will say it is xy is equal to a square by 2, right?
Yeah.
In the new axis. So your c square, xy is equal to c square. Your c square actually stands for a square by 2 in the other form, right?
Yeah.
Are you understanding what is happening?
Yeah.
Basically, you had the normal rectangular hyperbola where the asymptotes were at 45 degrees, right?
Yeah.
These were the asymptotes actually. But now what you are saying is you have shifted your viewpoint and you are now looking at it like this, right? From here, right?
Yeah.
Your y dash is this and x dash is this, then your hyperbola equation is transformed and looks like xy is equal to a square by 2, right?
Yeah.
If you look from here and here, it is equation is x square minus y square is equal to a square, correct?
Yeah.
So that is the thing. It is just a simple rotation. Now, if you have, now mostly we will use the form xy is equal to c square. If you have this form for a rectangular hyperbola, parametric point on it would be ct comma c by t, just like in parabola the way we did it, right?
Yeah.
Parametric point on this hyperbola is ct comma c by t. And now what we can do here is write the equation of tangent at t to the hyperbola xy is equal to c square. Now you could do by calculus, but you should remember that we have a direct way of doing it, right?
Yeah.
We replace 2xy with x1y plus xy1, right?
Yeah.
So xy is x1y plus xy1 by 2, which goes on the other side. So this becomes this, right?
Yeah.
This is at the point x1 comma y1. If we use parametric points for that, we'll get cty plus x into cyt is equal to 2c square, right?
Yeah.
So you get ty plus x by t is equal to 2c. This is your equation of the tangent. You don't need to remember it. You can just derive it like this whenever needed, right?
Yeah.
Slope of the tangent becomes minus 1 by t square is the slope of the tangent, right?
Yeah.
And similarly, you can find whatever other stuff you need to do about this. But you don't need to remember stuff here. Just know that how the equation xy is equal to c square has been obtained. It is just by rotating a standard hyperbola a little bit. The axis has been rotated, right?
Yeah.
And what is a parametric point on this and how to write tangent normal and stuff, right?
Yeah.
So that is your theory. After this point, you can do a few questions and see if we are understanding. So, for example, question is this. The number of points on a rectangular hyperbola xy is equal to c square from which two tangents can be drawn through the ellipse Hello. Uh, can you hear me now?
Yes, sir, but there's like static in your voice.
Hello, hello. Can you hear me clearly right now?
No, sir.
Okay. Uh, there is some internet issue. Uh, hello.
Yes, sir.
Okay. Is it better right now? Not.
It's clear enough for me to understand. So,
Okay. So we are saying number of points on xy is equal to c square, from which two tangents can be drawn to x square by a square plus y square by b square is equal to 1, where 0 is less than b is less than a is less than c, and the tangents are perpendicular to each other, right?
yeah,
So we need points on this from where you can draw perpendicular tangents to this, right?
yeah,
So for perpendicular tangents to the ellipse, we remember that the locus of such points is director circle of the ellipse, right?
yeah,
So points from where perpendicular tangents can be drawn will always lie on the director circle, which is this, right?
yeah,
But now a question is said that it also lies on this, right?
yeah,
So basically we have to figure out like what is the point of intersection on of this curve and this curve, right? Which lies on both. Correct.
yeah,
Then only it will be on the hyperbola and you can be on the director circle also, right?
yeah,
So don't try to solve it directly because you'll get a fourth degree equation and all, right? What you should
yeah,
do is maybe just take a parametric point on the hyperbola like this, right?
yeah,
And you can put that point in this. This should satisfy this. So it should be c square t square plus c square by t square is equal to a square plus b square, right?
yeah,
This must be true for any such point to exist. So how many solutions are there to this equation? If you know the number of solutions, you know how many such points are possible. Correct?
yeah.
Okay, so how will you decide number of solutions for this?
There are too many variables.
Yeah, so don't try to solve it. What you should do is see C and A and B are not variables, they are fixed. No?
Yeah,
The only variable is T. You're solving for T, no? If T are different, then you get multiple points.
yeah,
What you can say is the left hand side is the sum of two positive things, right?
yeah,
If you apply AMGM, what can you say about this? C square T square plus C square by T square divided by 2 should be greater than root over this, right?
the product. Yeah,
T square gets cancelled is equal to C square. So therefore, left hand side is greater than equal to 2C square, right? Right?
yeah,
And if you see right hand side is A square plus B square and A is less than B is less than C.
yeah,
So this is always less than 2C square.
yeah,
So therefore, what will happen is that no solution is there, right?
Yeah.
So there is no such point from where on a rectangular hyperbola from where you can draw perpendicular tangents to an ellipse. If this condition is true, right?
Yeah.
If this condition was not true, then you might get some solutions. Makes sense?
Yeah.
What you should do is now go through your JEE questions now for all of the conic sections, right? We are done with the theory and all. You should practice from here. If you do it in the next 2-3 days, you will begin to feel pretty confident about this chapter because questions from this chapter are not tough. It just tests whether you know your stuff or not. Okay. So
Yeah.
it will be pretty easy only. What we'll do next is we'll do physics chapters, whatever are problems for you. Next will be the physics chapter which you had listed, whatever is the first one. Okay.
Yeah. I think it's magnetism.
That's so we'll do magnetism, we'll do it, and we'll finish
Yeah.
that and then go ahead to the next one. Okay. Your scores and all came for last test.
Yeah, I did.
The full test, full syllabus.
Yeah. The paper was actually easier than I expected, so I got a good score. I got 261.
Hmm. This was on Sunday.
It was on 6th.
Okay, so Sunday only, I think. Yeah. Okay. Fine. The next test is when? Tomorrow.
Tomorrow. Yeah.
That is also full syllabus.
Yeah.
Okay. Fine. We'll continue on Monday onwards then.
Okay.
Okay. Bye.